Good day. I am Marina Lobicheva, the Scientific Director of the MAGUS project. Today, we are filming a review for professionals who cannot imagine working with a microscope without color illumination. Microscopes in universities and medical laboratories are used extremely intensively, so high demands are placed on their reliability. People also undergo significant stress. Daily 8-hour research sessions on a microscope cause fatigue and discomfort. The neck becomes stiff, the back hurts, and the hands get tired. Workplace exercises and massages solve the problem, but after about 5 years, the fatigue accumulates and manifests as a herniated disc in the spine or impaired blood flow in the neck vessels. Occupational diseases have become commonplace. A surgical nurse complains of heaviness in the legs and dry skin on the hands, a hairdresser of joint pain, a graphic designer of deteriorating vision. People work hard, so workplace ergonomics is a necessity, not a whim. The MAGUS Bio 260 addresses both issues: the reliability of the device and user comfort. The reliability of the microscope is confirmed by a 5-year warranty, so we won't dwell on this issue. However, let's take a closer look at the ergonomics of the model. By rotating the tube of the visual attachment, you can choose a comfortable eyepiece height, so you don't have to hunch over, or conversely, stretch too much. A straight posture is very important. The handles for the focusing mechanism and stage control are positioned low, so the wrist doesn't get strained. The finger indentations on the fine focus knob on the right emphasize that the device was designed with attention to detail. The light control handles are located in a single working area. Brightness adjustment, field diaphragm, and Abbe condenser. The slot in the Abbe condenser allows for the installation of a dark field slider or a phase contrast slider. Installing the slider saves time when switching research methods. The model is supplied to clinical diagnostic laboratories and medical universities. Therefore, the stand design includes a handle for carrying the microscope and a device for winding the cable. Anyone who has ever moved a microscope from one room to another will appreciate this convenience. The coated revolver creates a comfort that you quickly get used to. Experienced users reduce the brightness in advance when switching from a 100 times objective to a 4 times objective. Now these actions are no longer necessary. The microscope itself will adjust the light brightness when the revolver is turned. The Bio 260 is similar to a reliable German crossover. Such a car may fall short of a Bugatti in speed, an SUV in off-road capability, and a convertible in elegance. But it is equally good in city traffic jams, on the highway, and on a mountain serpentine with challenging sections. The interior of this crossover will provide comfort to the driver and passengers, and the trunk will delight with its spaciousness. This car is suitable for middle-class individuals who value versatility and reliability. Such is the MAGUS Bio 260 series. The microscope was designed for people with a focus on human comfort, while retaining the necessary functions for visualizing the research object at the limit of the objective's resolution. Planachromatic objectives, wide-field eyepieces, and color illumination adjustment ensure image quality. The microscope's design allows for the installation of additional accessories which, in addition to bright field, enable 4 more research methods: dark field, phase contrast, polarization, and fluorescence. Intelligent lighting control of the microscope enhances the comfort and speed of routine work for researchers, and the smart function will help students more easily enter the profession and gain the necessary experience. Now let's examine in detail the nuances of the Bio 260 model. The only component that interacts with the research object is the objective. The objective forms an enlarged image of the object's structural details, and therefore, it determines the resolving power of the microscope. Microscopes of the MAGUS Bio 260 series are equipped with planachromatic objectives designed for infinity. The parfocal height is 60 millimeters. The objectives correct chromatic aberration for 2 wavelengths. The contours of the object are clearly delineated, color rendition is not distorted, and the plan correction rectifies image curvature across the field of view. Such objectives are standard for clinical diagnostic laboratories. The microscope set includes objectives with magnifications of 4, 10, 40, and 100 times. The color coding corresponds to magnification according to international standards. Red is 4, yellow is 10, blue is 40, white is 100. Other objectives are available upon additional order. A 2x objective with an 11mm field of view for scanning the object and locating the research area. A 20x objective provides intermediate magnification between 10 and 40x, suitable for urine analysis. A 60x planochromat dry objective is suitable for intracellular research. The 60x immersion plan apochromat guarantees a resolution limit of 200 nanometers. Therefore, we recommend this objective for scientific research. A 100x objective with water immersion is suitable for tasks where a resolution limit of 260 nanometers at 1000 times magnification is sufficient. The microscope set includes 10x eyepieces with a field of view of 22 millimeters. The exit pupil position of 20 millimeters allows for use, both with and without glasses. Flat rubber eye cups on the eyepieces protect the glasses' optics from scratches when in contact with the metal body of the eyepieces. The mounting diameter is 30 millimeters. The design of both eyepieces includes diopter adjustment to compensate for the observer's eye ametropia. Other eyepieces are not included in the set and are purchased separately. Let's see. What advantages a field of view of 22 millimeters offers compared to the usual field of 18 millimeters? 22 and 18 are the diameters of the circle. From school mathematics, we know that the area of a circle is pi r squared. This means that the field of view of the eyepiece with a diameter of 22 millimeters has increased by 1.5 times, compared to the field of view of the eyepiece with a diameter of 18 millimeters. The objective correction plan corrects the curvature of the image across the field of view. The lab technician works with the full field of view of 22 millimeters without additional refocusing. Therefore, fewer fields are viewed for the analysis of the entire specimen. The image quality of a light optical microscope is equally determined by the optics and the instrument's lighting system. Lighting also affects the researcher's comfort and the quality of photographs when using digital cameras. Kohler illumination setup will allow each objective to work at the limit of resolution. Eliminate glare, images of dust on the illuminator or specimen, remove edge darkening, and ensure uniform lighting. Now let's consider the design of the Bio 260 series microscopes. I don't want to miss anything, so let's go in order, from top to bottom. Visual head. The series offers two models, a trinocular and a binocular with a built-in camera. The trinocular visual head allows for the installation of a camera in the vertical channel to display images on a digital device screen. In the vertical output of the visual head, there is a C-mount adapter for securing the camera. The division of the light beam is fixed. 50% of the light goes to the eyepieces, and 50% to the visualization channel. The image is simultaneously sent to both the eyepieces and the camera. The binocular head with a built-in camera enhances the convenience of working with digital devices. This model is suitable for classrooms. Students connect via Wi-Fi to the teacher's microscope to study the material, and the teacher connects to the students' microscopes to check the results of the laboratory work. By rotating the tubes of the visual head, the user selects the eye relief height, according to their own height. Infinity optics allow for the installation of additional modules between the stand and the visual head. A fluorescent attachment is supplied for the Bio 260 series. Let's consider the revolver. The MAGUS Bio 260 revolver allows for the installation of 5 objectives. The standard package includes popular objectives of 4, 10, 40, and 100 times magnification. An additional objective is installed in the free slot, while the other objectives remain in the revolver. The revolver is directed towards the stand. Thus, the user sees the objective that has introduced the light path and the space above the stage remains free. As mentioned at the beginning, the revolver is encoded. What does this mean? And what are the advantages of an encoded revolver? Objectives with different magnifications transmit light to varying degrees. So, when working with a microscope, it is necessary to adjust the brightness when changing objectives. Moreover, the brightness of the image in the eyepieces increases sharply when switching from a higher magnification objective to a lower magnification objective. Switching from a 100x objective to a 4x objective causes a bright flash of light that can be blinding. Therefore, the user remembers the need to reduce the light source intensity before changing the objective. Intelligent brightness control solves this problem. The microscope remembers the brightness for each objective selected by the user and automatically sets this brightness when the turret is rotated. If necessary, the user can change the light source intensity. The microscope will remember the new setting and will set this brightness next time. Intelligent control enhances comfort and saves time. The dust cover above the turret closes the slot for installing the analyzer. The polarizer is mounted on the collector. Researchers who study objects in polarized light will appreciate the convenience of such a polarization device setup. Installing the analyzer into the optical path does not require removing the visual attachment. The objectives have already been reviewed. I will once again draw attention to the parfocal height, which is 60 millimeters. This characteristic will be necessary if you are going to purchase an additional objective. Objectives with a parfocal height of 33 or 45 millimeters will not be suitable here. The revolver holds objectives of 60 millimeters. Therefore, the additional objective should also be 60 millimeters. The stage. The stage lacks a retractable rack along the x-axis. The belt drive ensures smooth operation and enhances user convenience. The user will not accidentally scratch their hand on the rack. The slide holder can secure 2 slides. The slide holder is attached with 2 screws and can be removed during manual scanning. Under the stage is the condenser. The Abbey Bright Field Immersion Condenser is fixed in the bracket's spring mechanism. 2 screws center the spring holder along with the Abbey condenser, and a 3rd screw secures the condenser to the holder. The dovetail mount allows for easy replacement of the Abbey condenser with a dark field or Zernike phase condenser. This design ensures the installation of interchangeable condensers along the optical axis without additional centering. The Abbey condenser allows for easy switching to other research methods without replacing the condenser itself. A dark field slider or a phase contrast slider is installed in the condenser slot. The color illumination setup positions the Abbey condenser along the optical axis and at the precise height relative to the research object. The adjustments are made using the tenfold objective. Afterward, when changing the objective, only the aperture and field diaphragm openings need to be adjusted. I will not dwell on this topic in detail. We will offer a separate video with a step-by-step guide on how to set up color illumination. Light source. The illuminator is equipped with a 3-watt LED. The LED has a lifespan of 50,000 hours. The LED does not change its color temperature when the brightness is adjusted. This indicator is important when working with a camera. Lenses with different magnifications transmit light to varying degrees, so when changing the lens, it is necessary to adjust the brightness. The color temperature of the LED does not change. Therefore, the camera will not require adjusting the white balance with each lens change. Next, let's look at the liquid crystal display. The screen displays the magnification of the working lens, the brightness of the light source, the operating mode, sleep mode, and eco mode. Using the screen, the user encodes the revolver, locks the brightness adjustment, sets the sleep mode and the auto-off timer. The coarse and fine focus knobs are coaxial, located on both sides of the stand. The right fine focus knob has special indentations for finger control. Fine focusing is required for precise focusing on the object and for refocusing the microscope when changing the lens or specimen. The ring on the left side adjusts the tension of the coarse focus movement. The user sets a comfortable tension for operation. The coarse focus travel is 30 millimeters. This distance between the stage and the objective ensures comfort when changing specimens. Another parameter of the focusing mechanism is the fine focus graduation. On our microscope, the graduation is 2 microns. For a student and routine microscope, such a step is optimal, as it guarantees both speed and precision of focusing. At the back of the stand, there is a microscope and a special handle for carrying. The device for concealed placement of the power cord enhances the aesthetics of the workspace and the safety of carrying the microscope, simplifying the storage of the device. So, let's summarize. Planochromatic objectives and eyepieces with a field of view of 22 millimeters will provide an image without spherical distortions at the edges. Cooler illumination will allow each objective to work at the limit of resolution, removing image artifacts. The revolving nosepiece remembers the brightness for each objective selected by the user and automatically sets it when rotated. The economical 3-watt LED will last 50,000 hours. The MAGUS Bio 260 series offers a choice of 2 models, differing in the visual attachment, a trinocular and a binocular with a built-in camera. By rotating the tubes, the user selects the eyepiece height according to their own height. The mechanism for adjusting the stiffness of the coarse focus allows the user to choose a comfortable stiffness for adjustment. The stage without a sliding rack and long control handles enhance working comfort. The handle in the stand and the concealed placement of the power cord ensure ease of transport and storage. The ergonomic features of the MAGUS Bio 260 make this series appealing for use in clinical diagnostic laboratories. A range of accessories has been developed for the microscope. Additional objectives and eyepieces expand the magnification range of the microscope. The phase contrast device, dark field slider, polarization device, and fluorescent attachment expand the contrast methods for studying objects invisible in the bright field. Digital cameras display the microscope image on a monitor and save it as files. The software measures objects. The calibration slide for measuring objects works in conjunction with an eyepiece with a scale and the camera software. I'm sure you will appreciate the Bio 260 series microscope as you would a reliable German crossover. Visit our MAGUS demo rooms to personally experience its convenience and reliability. Bring your samples for examination, and together we will select the model and accessories to meet your needs. See you soon.